And if you don't have the epigenome, the skin cell will forget what type of cell it is, and it might turn into a brain cell, which may not be that bad, but if your brain turns into a skin cell, you've got a problem. And I think that's largely what aging is. Stuff happens when you get older, right? You start to get hair growing where it shouldn't, ears, nose, back. That's cells losing their identity. Cells go, I can't remember what I'm supposed to do. I'm not reading the right genes anymore. So when you go out in the sun, and not like today, but on a day where there's a lot of sun, you'll break your chromosomes. And in the effort that the cells go to stick the chromosome back together, the DNA isn't just flailing around, it's actually bundled up. The cell has to unwrap it, recruit proteins to help, join it together, and then they have to go back and reset the structures. And that resetting of the epigenome happens about 99%. That 1% is the aging process.
So over time, histones are not returned to the right places, and DNA methylation is added in places where it shouldn't be.
We can read that methylation pattern, and I could tell you how old you are, exactly, and when you're even going to die.
How could you tell that?
Well, it's a clock. We call it the Horvath clock, named after my good friend Steve Horvath. And so these little chemicals that accumulate on the DNA, like plaque on the teeth, we can read that, and the more you have, the older you are, biologically. The clock of aging is due to the loss of the information in the cell. And one way to accelerate that is to go break a chromosome.